limiting reactants. One of my favorite topics to talk about. However, this video isn't going to really walk you through the problem. I'm just going to be talking about the concept of limiting reactants in this video, and it will be quite silly, but I think it will give you a really good understanding of what you will then be doing in the homework assignment once you actually apply the chemistry to this idea. So it can be one of the more difficult types of problems to do in chemistry, but I think through this video you'll understand the basics of what you're doing better. That's my goal, at least. And that's the reason I kind of make it silly. So limiting reactants, we kind of talked about this concept in the percent yield video. All we mean when we say limiting reactants is that one of the reactants, right? You can have one or more, you could have two or three reactants in a chemical reaction. One of those is going to limit the extent of your reaction. So the other ones you'll have extra, right? Kind of like we talked about in the percent yield video. But one of them will pretty much determine the amount of product that you can make. That's the whole idea with limiting reactants. And you will be asked to figure out which reactant is limiting based on some calculations, right? And this video, like I said, is very silly, and it will make the idea much more clear. So to learn about limiting reactants and to understand how you will navigate these types of problems, we will be talking about hot dogs. Yes, hot dogs. I like hot dogs. They're silly. They have a very easy relationship of dog to bun ratio, and I think it will make you understand how this works. Right? So also, before I talk about these slides, which are going to be ridiculous, when I say hot dog, I mean a completed hot dog that includes both a dog, which will refer to just a naked hot dog, and a bun together. So dog will mean a naked hot dog, bun is the bun, and then when I say hot dog, I mean the dog and the bun together. So when you go to the store, you go to buy some dogs, right? And they come in a pack of 10. So here's your 10 dogs. Very nice, right? And you want to make some hot dogs. So you go to buy some buns. And wouldn't you know it, the buns come in a pack of 8. Very frustrating, right? So here's our setup. This is actually a chemical equation that we're going to have, right? Dog plus bun gives us hot dog. So we want to figure out how many complete hot dogs we can make. This is exactly what you're going to get in a limiting reactant problem on your chemistry homework, except it's going to be a little more cryptic, right? It'll say you have this much oxygen and you have this much hydrogen. How much water can you make? But the idea is the same. So we're going to take our 10 dogs and our 8 buns, right? And we want to make hot dogs. So how many hot dogs can we make? Well, you probably had already figured it out, right? We can make 8 complete hot dogs. And in your head, I'm sure that was very easy to do, but let me explain what you actually did very quickly in your head, which you won't be able to do very quickly once you apply this to chemistry. But what you did is you first figured out how many hot dogs theoretically you could make with the 10 dogs, right? So in your head you said, okay, if I have 10 dogs, I can make 10 hot dogs, theoretically, right? Then you go over to the buns and you say, well, with these 8 buns, I could theoretically make 8 hot dogs. So with the dogs, I could make 10. With the buns, I could make 8. In reality, I'm going to only be able to make 8 because I'm going to run out of buns, right? So you figured out separately how many you could possibly make, and then you picked the smaller number. That's how it's going to work for your chemistry problems as well. So for chemistry, we call the buns the limiting reactant because we have the number of buns we have is going to limit our reaction. We run out of buns. So whatever reactant you run out of is called your limiting reactant. The dogs, on the other hand, we had extra. So those are our excess reactants. Okay, and then the question will go further. So how much extra do you have? Right? how much excess reactant do you have? And of course, you can do this pretty quickly in your head. You'll say that you have 2 dogs in excess, right? But again, you did something in your head very easily that won't be very easy when you apply this to chemistry. So what you'll have to do when you do this to a chemistry problem is you'll take the amount you started with, or that you formed, I mean. So you'll say, okay, well, I made 8 hot dogs, right? Those 8 hot dogs I made required 8 dogs. So you used 8 dogs. And then the last thing you'll do is you'll say, well, I started with 10 dogs. I used 8. So 10 minus 8 means I have 2 left over. And that's what you'll have to do when you're kind of working this out for a chemistry problem. It will take a little bit more effort to do this. But that's essentially a limiting reactant problem. Okay, you're given the amounts of 2 of your starting materials. You work them separately to figure out theoretically how much they could make. And then you always pick the smaller number because you're going to run out of that reactant, right? And then at the end, to figure out how much you're left over with, you work backwards. Start with how much you formed, work back to what you had left over of, and then subtract it from how much you started with. So the steps here, which I just explained, when you get a chemistry problem, you'll follow these same steps. So you'll take each reactant separately and convert it to the product. So that's going to require 2 stoichiometric calculations. Usually that means 2 mass-to-mass calculations. So you'll take the mass of one reactant, convert it to the product, and then you'll take the mass of the other reactant and convert it to the same product. And then you'll compare those numbers. Okay? The way you determine the limiting reactant is it's the reactant that produces the smaller amount, right? Because it ran out. The other one could produce more, but you can't because you ran out of the other reactant. That makes it the limiting reactant. And that's the answer when it says how much can you produce. It's always the smaller number. It's not possible to make the bigger number. Then, to calculate the amount of excess reactant, you'll take your answer and convert it to the amount of excess reactant. That's going to give you the amount produced, or that the amount that you used to produce that product. So there is one extra step where you take that amount of excess reactant that was used and you subtract it from the amount you started with. Okay, so I know the words are very confusing to look at. So when you apply this to your homework, I highly, highly, highly recommend you watch the tutorial video, because the tutorial video will walk you through the entirety of problem number 1. Right? Remember, you always need a balanced chemical equation. Number 1's nice because they gave it to you. The rest of them don't, so you need to start with that first. But then you're going to be going through these limiting reactant problems just like the hot dogs. But again, it's much more complicated because it's almost like if I were to apply to the hot dogs, instead of saying, okay, I have 10 dogs and 8 buns, these problems are more like you have 20.6 grams of dog and 5.7 grams of bun, right? How many grams of hot dog could you make? It's going to require extra conversions to convert from grams to moles, and then moles back to grams to do your calculations. So watch the tutorial video. It will walk you through it very slowly. You can pause as you go to make sure you understand it. But essentially, a limiting reactant problem, you end up doing a mass-to-mass conversion 3 times, a total of 3 times, plus the extra little subtraction you have to do at the end. Don't forget that. All right, so thanks for watching the video. I know it was silly. Hope you enjoyed it. And now you will never forget how to do a limiting reactant problem.